Hello everyone, and welcome to this lecture on the overview of DevOps. So DevOps is a set of cultural philosophies, practices and tools whose goal is to deliver high quality software products efficiently and quickly to their customer or end user base, and also to upgrade and improve these products at a much faster pace in response to customer feedback compared to older approaches like traditional software development life cycles. So the fundamental idea is we want organizations to be able to align their products more quickly and better with customer needs, and the end result of that is that these organizations or companies will then achieve a competitive marketplace advantage. Alright, so that's the kind of high level overview of DevOps. So let's go and take a look and see how it works. So we are going to look at the so-called DevOps pipeline a bit later in a part of this lecture, but you can see here you are going to start off by building. Building means compiling your code, okay, your application code. Then you're going to run some tests on it, and then you're going to release it to the customers. Typically the customers will access it on a production server, okay, and then you are going to monitor the running application. You're going to see how well the application is running. Is it running efficiently, whether there are any errors or issues with the application, and then based on the data that you get from the monitoring and also the feedback that you get from the customers, you can plan for the next iteration of your software product. So maybe might be adding in a new feature, might be fixing an existing bug, and so on. Okay, so how does DevOps work? What's the key idea behind the DevOps model? Well, the key idea is that the software development team and the IT operation teams are no longer siloed, whereas they now currently merge into a single team where members of this team will develop skills that to work across the entire application lifecycle, meaning all the way starting from development to the actual deployment of the app on the production server. Okay, so what do I mean by silos? Okay, so if you look at traditional way that IT is used in many organizations or in many software houses, you have a team of developers and also testers, and then you also have a team of what we call the IT operations people. So the developers obviously you will write the code, and then you have testers who will test the code, right? The code, when it's developed, will typically be deployed or run on a actual server. Okay, so you have a piece of hardware, an actual physical server. You install some kind of server software on it, like Windows Server 2016, Windows Server 2020. You might install a Linux distro like Ubuntu, CentOS, Red Hat Enterprise Linux. Okay, and then on top of that, you might run Windows IIS, or you might run, and the Nginx web server or the Apache web server. You might run Tomcat. So you might run a variety of software on which you will deploy your actual application. And the management of the server infrastructure, the management of the networking, the routers, the firewalls, all of that is done by the IT operation teams. So traditionally, these two groups of people are generally working in silos. So the word silo means that they are working in kind of in their own area, okay, and they don't really communicate much with each other. So the standard scenario is that the developers, once they finish writing their code, okay, they hit the compile button, the code compiles fine, everything is fine. That's it. That's the end of the day. They go back, okay, they don't worry about the servers. They don't care how the servers are running. They don't care what's the server operating system. They don't care what port numbers their applications are going to be exposed on. All of that for them is irrelevant. Okay, they just pass it over. Then you have the IT operations people will take that code base, will deploy it onto the actual production server, will make sure the production server is running fine, and so on. Okay, so this seems to work fine until there is a problem with the app. So your app that's deployed in the production server crashes. Okay, so when it crashes, people are going to start pointing fingers. Whose fault is it? So typically the IT people, the IT operations people will say, oh, there's a problem with the code was not written properly. So back to the developers. Developers will say, oh no, actually we tested the code properly. It's only the IT operation people who do not know how to run the server properly. The server doesn't have enough memory, or the operating system was not updated on the server properly, whatever. So there is a back and forth between the developers and the IT operations team. So the result of that is when the customer encounters a problem, they have to wait for a long time before the problem gets resolved, because the development team and the IT operations team are spending a lot of time fighting with each other and blaming each other for whatever problems that arise. And a lot of times this is also due to misunderstanding, and also because both groups of people don't really understand what their work entails. So like developers and testers probably don't know that much about, say, Windows PowerShell or Linux Bash Shell scripting. They do not know how to set up a server. They don't know what's the port numbers. They don't know how to find out what subnet my server is running in. All of that is irrelevant for a developer, right? Because developers, okay, I just write my C# code, my Java code, my Python code, write the code, compile, that's it, end of the day, okay, that's it, go back home, that's it, finish. Okay, and server people also, of course, they don't really know, what may cause an application to crash. Maybe it's the code itself, maybe it's the server. Okay, so they don't kind of really understand that too. So there's of course a lot of issues. Then the other thing, of course, is developers, they're constantly changing their code. They want to add in new features, and if you use things like Agile, okay, or Scrum as part of your software development methodology, you're going to be constantly adding in new features in response to your customer feedback. Now the problem with operations people is they want stability. That means they don't like change. Why is it that they don't like change? Is because when you change something, when you deploy a new app, when you deploy an app with a new feature, there's always a chance that the server will go down, and then they will get blamed for it, right? So the IT people, the IT ops people are the first people to get blamed. If the server crashes at 3 o'clock in the morning, means the boss is going to call them at 3 o'clock in the morning, means they need to go to the office at 3 o'clock in the morning and figure out what goes on, what's wrong, right? To make sure the server goes up again. So of course, the IT operations people don't like change. They want things to be stable, but that's not what developers want. So of course, there's going to be this back and forth, okay? And this becomes a big issue over time, like I said. So if customers face a problem with the app and they report it back to the company, then there's going to be a big war now between the developers and the operations team to decide how to fix the bug, to fix the problem. Okay, so now the DevOps model is suggesting, well, you guys better work together. The software development people and the IT operations team better work together as a single team, where everybody in the team has skills to work across the entire application lifecycle. So that means that people who are traditionally in IT operations now need to know a bit about software development. They need to know a bit about C# or Java or Python, how to compile code, how does the IDE work, what are the issues when you write code, you write loops, what's the problem, you might have a endless loop, or those kind of things that developers think about. And developers now as well need to know, oh, okay, there's such a thing as Linux, there's such a thing as Linux Bash Shell scripting. You can't say, oh, I'm a Windows guy, I don't ever want to know what Linux is. Linux is for nerds, and I'm a Windows guy, I don't ever want to touch Linux. Okay, so now you have to learn about Linux shell scripting, you have to learn about PowerShell scripting, blah blah blah, and so on. So now basically it requires both members from both teams to kind of learn skills that are relevant to each other's domain. Okay, that's what DevOps is essentially about. The second thing that DevOps is about is they're going to use practices that are based heavily on automation. This is a key principle we're going to see over and over again. And the idea is basically whatever you do in DevOps is going to be automated as much as possible. Automated means you don't have to manually do it. So when something is automated, you just basically click a button or you type in the name of the script file, press the enter key, then everything happens like magic. That's what you want in DevOps. You want to automate everything, okay? And you are going to use a tech stack and a tool chain which are going to help you do all these things, to automate all these processes, okay? So we're going to talk about the tech stack and the tool chain in upcoming lectures. All right, so that's essentially the heart of DevOps, right? So what are the benefits of DevOps? Well, obviously there's speed, because now there's better understanding between the developers and the IT operations team means that the software products get delivered faster and more frequently. And when you get feedback from your customers, like let's say your application crashes, or they want to have a new feature or whatever, then you can act on that feedback faster. You can roll out your new upgrades in your product faster, which means that you make your product more attractive to customers in a competitive marketplace. Okay, so DevOps also focuses on quality, and the way they focus on quality is by ensuring that you have testing at all stages of the CI/CD pipeline. So I'm going to talk about this CI/CD pipeline later on. CI/CD is a very key component of DevOps. So when we work on CI/CD, you're going to see that we do testing at all stages to ensure any changes that you make to your code are safe. So every time the customer feedbacks, they say, okay, there's a bug in your code, or okay, I want to have some new feature in the code base. And every time the developer changes the code in the existing code base, so you either change it to fix a bug or you change the code to put in a new feature, you want to test the changes to make sure that everything is still working. Okay, and that's very important in DevOps. And then of course, you want to make sure that when the application is running on the production server, you are going to monitor it all the time. You're going to monitor how well the application is running, how much memory is consuming, how much CPU time is consuming, how much network latency is consuming, how well is it responding to all the user requests that are coming in from the web, and so on. So you want to monitor this, you want to log the processes involved in the application in real time. Okay, and that's also as part of quality and reliability. Then the other benefits, of course, is improved collaboration, because now the idea is that there's shared ownership and accountability between the IT and operations team. So before DevOps, basically what happens is you have a war between these two groups of people. So the developers will blame the operations team. You guys don't know how to write your, you guys don't know how to maintain your servers. Your servers are not maintained properly. Then the operations team will say your code is crap. That's why your code crashed. That's why the customer, when they try to access your app, the app crashed. So now both of these teams are basically blaming each other. So the idea with DevOps is hopefully that there's improved collaboration. Everybody takes shared ownership for the product. Okay, so the idea is hopefully that now if everybody knows what everybody else is doing, so the IT people know what is it, the IT and operations people know what coding is all about, and the coding people figure out what server maintenance is all about, then there's less conflict and misunderstanding, and therefore there's better efficiency. Then scale. Okay, scale is very important for today's applications, because today's applications don't just normally run on 1 or 2 servers. So like 20 or 30 years ago, generally companies, they run their apps on one single web server where they expect only maybe 30 or 40 customers will access their apps. Nowadays, if you are working in a multinational company, you're writing apps that are probably going to be accessed by customers all over the world. So we're talking about maybe 20,000 customers, 30,000 customers, which means that your app needs to be able to do load balancing from all the requests that are coming in from the customers. And so to do load balancing, you need to have set up particular infrastructure. You need to have multiple servers running. You need to have a load balancer. You need to balance out the network traffic, and so on. So all of this is about scale. Okay, scale means now we are talking about applications that run on hundreds or even thousands of servers that are accessed by hundreds or thousands or even millions of customers. Okay, which is of course the case if we talk about social media companies like TikTok, Instagram, Pinterest, Facebook. They're all accessed by hundreds and millions or billions of customers. So we're talking about scale here, right? Okay, so DevOps is really, really important for scale, because once you start moving to writing code and maintaining the running of the code on hundreds and thousands of servers at the same time, you can't do it manually anymore. It's not possible to do it manually anymore, right? Okay, Facebook cannot employ 100,000 system administrators to go down to their data center and look after every one of the 100,000 servers they have in their data center. That's not possible anymore. So DevOps is about scale now, and you want to automate all your infra processes, your software development processes. Everything is automated so that it can scale effectively. Okay, so that's the benefits. What are the drawbacks or the challenges? So the main drawback is actually a cultural drawback. So a lot of times when people get on board with DevOps, they will start learning all the DevOps tools. They will learn, okay, I know how to use Git, I know how to use Jenkins, I know how to use Docker, I know how to use Kubernetes, I know how to use Ansible, I know how to use Puppet, I use Chef, I use SaltStack, I use AWS Terraform. So there's so many tools that are out there, and you can learn all those tools, but you still may not have the culture change. The culture change is you need to start collaborating. Collaborating between whom? Between the developers and the IT operations team. That is the main culture change. So without the culture change, you're still, even with DevOps tools, even you use all the DevOps tools change, you're still going to end up arguing with each other and blaming each other when there is a problem with the application on a production server. Okay, everybody is going to end up blaming each other. So that is what we want to change. Okay, and that's the most difficult part to change. Getting people to work with each other instead of blaming each other is the most difficult part of DevOps. So the most difficult part of DevOps is actually culture. It's not technology. It's learning to change people's mindset, right? Okay, so now let's assume you can change your mindset and culture. Well, then the other problem is you need to set up the organization structure to support DevOps. Because in DevOps, you no longer have a separate IT team and you no longer have a separate developer and testing team. You just have one single team, okay, that consists of developers and IT people that are going to work together for one single product. So you have a product-centric team. You don't have a functionality-centric team. So traditional companies is functionality-centric. I'm only a developer, so I only know how to write code, or I'm only an IT operations guy, so I only maintain servers. That's functionality-centric. So now with DevOps, you're going to be product-centric. So you no longer have these separate categories. You just have a group of people who are going to work together to maintain, develop, and run a software product. Okay, so you need to change your organization structure. The management needs to change the organization structure. That takes time. Then we come up to the tools. There are actually many tools. We're going to look at all these tools later on in subsequent lectures, but you need to learn quite a lot of these tools before you can get on board with the CI/CD pipeline in DevOps. So that's also going to be extra time because there's a steep learning curve involved. And finally, there is the initial transition period. So when you are transitioning from just working in a silo to working in collaboration, you need to set up all the DevOps tools on your machine. You need to get them to work together. You need to configure them. All of this takes a lot of time. So whether that's worth it or not is something that you have to decide, or your project team has to decide. Okay, so don't always think that DevOps is a great and wonderful thing. It's a great and wonderful thing if you can get it to work. If you can't get it to work, it's going to give you even more headaches than what you are currently having now. Okay, so that brings us to this first part of the lecture on DevOps.